Good evening, my dear students. Good evening. I hope all of you are doing great, right? So, in this session today, I'll talk about your continuity and differentiability part 1. Okay, this will be basically starting the definition of continuity, starting the questions on the continuity as well, and alongside we'll deal till rules of differentiation and various functions, how are the formulas look like. Okay, so before I begin, let me know whether I am clearly audible and visible or not. Yes, all of you, before I begin, I would like to know whether I'm clearly audible and visible or not. I think everything looks good. All clear, all good. Yes, let me just check once. Yes, sir. So everything is, audio is fine. No problem. Yes, so audio is also good. So let's start now. So let's discuss what we're gonna have in the session first before I begin with the class. So we'll talk about definitions of both, and we'll learn differentiation rules. We'll learn your various, basically 3-4 types are there: chain rule, quotient rule, product rule, and different functions, how the derivative looks like. Okay, any doubt regarding that? No, right? So let us start the class right now. So this is better just part 1, so I'm starting with the foundation of it, but this is very important because in next 1 or 2 months we have to complete our entire calculus, including integration, AOD, application of integrals. We'll all be completing that. So that's why this session becomes very important. So let's understand the basics right. Hi Bucky, how are you? I hope all of you, yes, FA went good. That's very, I'm very happy to hear that. Thank you for that reply. I did ask you to let me know, and I'm very proud of you, very glad that it went really well. Okay, so let us start now. Let's not waste any time. So in this class today, as I mentioned, I'll discuss the basics of it, but don't worry, as the this is just part 1 of this session. We'll have part 2 as well, and once this continues, you'll see more question solving, more sessions over here. Okay, all right, so let us start. Continuity of a function at a point. What it means? It means if in the function's graph, if graph of the function has no break in it, there's no jump in the graph. For example, let's look at some examples. So if I take an example of this function, y equals to what? Give me example. Sir, sin x. Do we know the graph of this? Yes, sir, we know the graph of this. The graph of this function is this, sir. It goes like this on both the sides. This is the graph of sin x function. It is continuous everywhere. There's no jump in the function. For all real numbers, for the entire domain, the function is continuous. Okay, most of the questions you gave came, sir. Hats off, sir. Great, thank you. But I can never guarantee that same question that I'm teaching will come. But similar can of course come. That much assurity I can give you. But I never give you blind guarantees like that. Okay, but great. I'm very happy that you did very good in your FA. Okay, so this is sin x function. Any other function that we can know of? Sir, y equal to mod of x. This is continuous. Let's look at the graph. Y equal to mod of x looks like this. Continuous or not? Does the given function has a jump or a discontinuity, means a break in the function? It does not. So given function is also continuous. Let's look at this function, y equal to mod of x minus 1. What is this, sir? This is basically a transformation that goes over here. This is the point 1, this is the point 0. So these are the examples of continuous function. Whenever there's no jump, no break in the function becomes simply continuous. And how do we define it? How do we solve it in the problems? So we find the limits. Yes. So calculus actually starts from limits, right? So we find the limits first of the function. So we find the limiting value of the function at the point A. So we'll check whether f of x limit value exists or not. If it exists, if this exists and is equal to what? Function value at A, then only we can call the given function to be continuous. Now how do you find limits? Of course, we have to find the left hand limit, right hand limit, and check whether they are equal or not. What's the meaning of left hand limit? Do you all remember what is the meaning of left hand limit? Yes, sir. If I approach the same function, limit x tends to the value A from left hand side. If I approach the same function for the limit from the left hand side, okay, all the best for that, Bucky. Continue. Okay, I have done some of the lectures of one shot. If you find it useful, you can use that. Use the notes. I would recommend you that. Don't worry, in a week or so, we'll have proper, we'll cover up most of the things that your college is doing. So we'll be, in tandem, we'll be in sync. Okay. So left hand limit will be what? Finding the limit of the function when you approach the point A from the left hand side. That's why we write A minus. Okay. So how do we write that in the function, in the part, sir? So we write actually this as limit of f of A minus h, means we replace the x value by A minus h. If x tends to A means h must be going to 0. So this is what the left hand limit looks like. I'm just recalling this. This has already been taught to you all in first PUC. Okay. And what about right hand limit, sir? This is quite simple. This also is quite simple. How do you go about that? We'll approach this time the same value function fx to the A from the right hand side. Means if this is the line, okay, when x is equals to A, the right hand limit comes from this side. This is your right hand limit, and the left hand limit comes from this side. When you approach from right side of the point A, that is right hand limit of the function. When you approach from the left hand side, that is left hand limit of the function. Yes. Okay. So you go about this and you write this as limit f of A plus h. In this case, you'll replace x by A plus h, and this becomes what? H tends to 0. H tends to 0. This is the form that we use for multiple questions to find left hand limit, right hand limit. I'll show you. Okay, I'll show some of the questions in this class. I have brought today more than 15 questions. I think 18 to 20 questions I have brought. I'll solve that, and then you'll understand how can we use this as well. And I'll tell you the tricks to solve questions of KCET understanding, means KCET type, that you can solve faster because you have to save time there. So we'll use LH rule over there. For those questions, we'll use LH rule, right? So this is how do you find limit. And for limit to exist, what is the condition? The LHL must be equal to the RHL. So for the given condition of continuous function, what we have? The LHL equals to RHL equals to function value at the point A. If all three is true, then only we call the function to be continuous. Even one is missing, it will become discontinuous. Clear? Let's move on. Sir, will you do only theory? Not at all. I have at least 8 to 9 questions on continuity only. So I'll not do just theory. Don't worry about that. Discontinuity at a point. Discontinuity at a point. How does it work? First of all, sir, if the graph is having a break. What do you mean by that? Let's say we go to the function like this. Okay. The open part here, and then from here, the function is going like this. This can be a function. It can't be a function. It is a function, right? Function, this is having a property of function or not? It is. Okay. Sir, how do we identify this? Let me show you. So let's say this is the point. This point is what? At point 1, this is, let's say, 2. And over here, what is the function? This is 4. Okay, this is 4. What is happening over here? This function is having a break in the graph of it. Means when you approach x A from right hand side, the f value, the fx value will go to what? That will go to 4. But if you approach x, so in this case 1 actually, so 1. From left hand side, the value is what? 2 actually. The fx becomes 2. So limiting value of the function is 2. Okay. And f of 1 is also what? 4. So f of 1 is 4. And limit of the right hand limit value is also 4. Then this function becomes right continuous at the point 1. This function becomes right continuous at the point 1. How come, sir? If you check limit of the function fx when x tends to 1 from right hand side is equal to f of 1, and they are both equal to what? 4. Then the given function is right continuous only at the point 1. After 1 it is continuous everywhere. Before 1 also it is continuous everywhere. But at 1 it is discontinuous. This is how we understand the jump or break in the function. Yes? Alright. Let us move on. Okay. So fx is not continuous at x equals to a, it is said to be, then in that case if it is not continuous, it is said to be simply discontinuous. And when can it happen? If LHL or RHL does not, or both does not exist. Okay, this can happen, right? The limit does not exist. In those cases actually, we will call this to be discontinuous. Either LHL or RHL or both does not exist. Okay, so when that is the case, next is what? They both exist but not equal. They both exist but not equal. That is also a case of discontinuity. Okay, they both exist and they're equal as well. This means what? This means limit exists. This means limit exists but not equal to f of a. Remember, for continuity, limit should exist, means LHL should be equal to RHL, and that should be equal to f of a as well. Just limit existing is not enough. So limit exists, great, but not equal to fa. This is the third type of discontinuity, right? This is called as discontinuity at a point. Let's practice this question, a very simple one. Examine the continuity of the function. I can give you a straightforward example. If you look at the function over here, this is what? This is a polynomial function. This is a polynomial function. Remember this always. Polynomial function always continuous, okay, in the respective domain. Same goes for sine function, cos function, tan function, all. Because the tan function is discontinuous at the point odd multiples of pi by 2. Okay, so try to remember for different functions what all points of discontinuity are there. So sine cos function continuous everywhere. Anyone in the class can tell me what is the domain of sine function? Can anybody tell me domain of sine function? Anybody? Domain of sine function is what, beta? Domain of sine function, anyone in the class? No one? All real number, right? So same way, sin x or cos x is again continuous everywhere in the domain. Domain is what? All real number. What is the next part? Tan x. Where is this continuous, sir? In the domain. So what is domain going to be? Please check. Domain is going to be, sir, all real number except for odd multiples of pi by 2. So the odd multiples means pi by 2, 3 pi by 2, 5 pi by 2. Those you have to remove. So at those places it is discontinuous. So remove that. That is tan x. Okay. Likewise, you can write for mod x, log x, right? So that is what it is meaning of continuous function. In this case, it is what? This is a polynomial function. What is this? This is basically a quadratic. Continuous everywhere. If you want to check the limit value. Limit of the function fx when x tends to 3. Achha, we can find here LHL, RHL also, but does not require. Okay, this is not forming any type of indeterminate form, right? We can simply put the value back in over here. We'll get what? 2 times of 3 square minus 1. How much you get? 9 into 2. 18 minus 1, 17. And if you look carefully, f of 3 is also 17. Okay, they're equal, right? It means fx is continuous at x equals to 3. Any doubt? I don't think so. If you have any doubt, let me know. Okay, but I don't think you'll have doubt in this. I know you're all good student, and yes, you have given your FA1 already, right? Algebra of continuous function. But I understand if you are feeling this way, sir, why you're doing this topic right now. We just finished FA1. I understand completely. I could have started with integration or AOD right away. Okay, and yes, most of you might have watched it as well, because this is a new chapter. But why I'm going with this chapter? No, because I am starting a new unit, which is very important. Do you understand this? Let me tell you what is calculus. Look at this. Let's try. Let's understand this very easily. Boards, KCET. Start. Number 1, C and D. Marks you check 17, 5 to 6. Number 2, AOD. 8 marks, 3 marks. Number 3, integrals. 18, 6. Number 4, AOI. 5, 2. Number 5, differential equation. 8, again here 3. Number 6, we have limits. 0, 2. This is the weightage of calculus, literally. So if I am starting this chapter, bacha, how can I start from AOD? Can I start from AOD? I cannot. C and D is worth 17 plus 5, 23 marks in your KCET score, KCET final rank. It cannot be ignored. That's why I'm starting right away over here. I'm not doing limits because this is a PU1 chapter. We'll cover that in PU1 one shots that we are doing. We are coming up with that as well very soon. But my point is, if we are doing continuity, in that I'm going to help you with the limits as well. I'll solve limits questions over there. It'll be a good revision. That's why we are starting with this and right from the basics. I hope you understand why I am doing this session over here. Right? Very crucial. Okay? Very, very crucial. Now this is algebra of continuous function. Trust me, boards has asked questions on this. Okay? And how important your board is to CET, that I don't have to tell you, right? So algebra of continuous function means if you have two functions, f and g, which are continuous at a point x equals to a, means function fx is continuous at the point a, functions gx is continuous at the point a, then automatically all four types of algebra of functions, sum of two functions, difference of two functions, product of two functions, and what is this? Quotient of two functions will be also continuous. Of course, in this case, g of a cannot be 0 because it is in the denominator, right? So all four operations, sum, difference, product, and quotient, all four will be automatically continuous. Clear? If you multiply a constant k to the function f or g, also continuous. If you take fog, now what about fog, sir? So for fog, g should be continuous at the point a and f should be continuous at the point ga. What is it? Fog mein what happens? For fog we should have g continuous at x equals to a and f continuous at ga. This is for fog. And what about GOF? What about GOF? For GOF you check. For GOF you'll have f continuous at point x equals to a and g continuous at the point f of a. Makes sense or not? Yes. Hi Akash, how are you? How was your FA, Akash? Bucky said that he had done exceptionally well in his FA. Let me know from you. You were also doing very good in the live that we conducted. Yes. And others, let me know how was your FA. Continuity in an interval. Continuity in a interval. Okay. So we have two type of interval. One is open interval. Another one is closed interval. So open interval is very simple. We draw the open interval, sir. Let's say this is A, this is B, and both the points are open. Both the points are open. Now tell me, in this interval A and B open, how many points will exist? Infinite number of points. Infinite number of points. For the function fx to be continuous in the interval A, B open. I'll repeat. For the function fx to be continuous in the interval open A, open B, it must be continuous at every single point that exists between A and B. Every single point in the interval A and B. That's the open interval wala case. What about closed interval? What about closed interval? So this is a little bit better. Okay, one step ahead. So for the closed interval, three conditions are there. Means this is a must. The condition of open interval is a must. For closed interval, this is, let's say, closed interval. AB, this and this is both closed. So open wala case is a must. Means every point between A and B, the function must be continuous. That is a must. And at the point B, you should have left continuous. What's the meaning of left continuous? Can you recall? I just taught it right now. Means LHL should be equal to f of B. Sir, why not RHL? Sir, why not RHL? Beta, because the RHL, any value after B is out of domain. All these values are what? Out of interval. So why would we consider that? Why do we need that? We don't need that, right? So exactly at the point B, we should have left continuity, and that is nothing but LHL equals to f of B at the point B. What about this one? So this is now easier. We'll have the RHL equal to f of A. This is called as right continuous at the point A. Does it make sense now? Right means from this side. So RHL should be equal to f of A. Okay, your FA starts on Monday. All right, Akash. Okay, so this is clear. Now important notes. A function fx is continuous if it is continuous at each point in its domain. I just explained this using what? The function sin x. Sin x is continuous everywhere because domain of sin x is what? Everywhere, all real number. Next, function continuous at entire real line is called as continuous everywhere. The same example, both. Fx is discontinuous on an interval if it is discontinuous at even a single point. Even a single point, then in that interval, means if I take an interval, inside that interval I find one point where it is discontinuous, then we call it is discontinuous in entire interval. The set of all points where f is continuous is called as domain of continuity. Domain of continuity. I hope this is also clear. Okay, don't worry, we'll move on quickly to the question solving also. Let me just discuss few points of continuity. Some examples are there, some common functions where it is continuous. So constant function beta is continuous everywhere. Identity function also continuous in the entire real number line. Next, what we have? Polynomial function continuous for the entire real number line. Rational function continuous everywhere except for where the qx is 0. Wherever the qx is 0, that we cannot have, right? So we'll remove that part out. We'll remove that part out. So continuous everywhere except for where the denominator is 0. Modulus function continuous everywhere. X power n, which is another polynomial type of function, continuous everywhere. Right? Now types of discontinuity. One is called as removable type of discontinuity, and other one is called as non-removable, or basically in this has second kind and first kind jump or infinite kind of discontinuity. Okay, we have seen the jump wala part already. I have drawn a graph and shown you, right, when the example I took. Correct now? Removable type. So this is what? When LHL and RHL are equal but not equal to f of A. Not equal to f of A, that is called as the removable type of discontinuity. And in this case, what happens when there is when this is not equal, actually when this is not equal, that is jump discontinuity. Infinite when either LHL or RHL both does not exist, basically tends to infinity or minus infinity, tend to minus or plus infinity, basically that is the case of infinity or infinite or discontinuity of second kind. Okay, as I said, I have questions also. We'll do the questions now. I know Only theory is not fun, right? We should do questions also. Let's do the questions. Great. So here, the second question is, first we solved that minor one on 2x square minus 1. That is a polynomial function. We discussed a few functions over there as well. Second question, does the following function have a removable discontinuity or a jump discontinuity? What is jump discontinuity? When LHL or RHL is not equal. Let's check LHL then. LHL first. We'll go from this one because this is less than wala case, right? So we'll have limit of x tends to 1 minus 4 fx. Okay, since it is already different branch, we'll write here x plus 2 and we'll write here what? Limit x tends to 1 directly. Same thing only, right? It becomes what? 3. This is my value of LHL. That is the value of LHL. Now let's look at the value of RHL also. In the RHL, what will happen? Again, we'll write limit fx x tends to 1 plus. Already we have a different branch, so we can just simply write the branch and write the limit value. So limit, we'll have x minus 2. Check here, x tends to 1. This becomes minus 1. Clearly we can see that RHL is not equal to LHL. So this represents what? This represents jump discontinuity. Jump discontinuity. I hope this is clear. Please check. This is the jump discontinuity. Correct, Baki. That's right. That is correct. Question number 2 is clear, I guess. Let's move on to the algebra of continuity question. Discuss the continuity of following function: sin x plus cos x, sin x minus cos x. So difficult, right? So we have two functions over here. Let's write function f is sin x and function g is cos x. Sir, they have not mentioned the interval also. You said that at a point A or at a point or a given interval, they must be mentioned. No, f is continuous at point A, g is continuous at point A. They have not mentioned that. Then we'll find the domain. Na? Check the domain of both. This domain is also all real. Also all real. It means in the entire real number line, sin x and cos x is both continuous. So automatically, sir, from the algebra of continuity, f plus g, which means sin x plus cos x is continuous in the entire number line. Same, sir, f minus g, which is sin x minus cos x, is continuous at the entire number line. Clear or not? Correct. Both are continuous. That's right. Next. Now this is a CET problem. This is a CET problem. Don't worry. I'll tell you the method to solve using, if it is a board question, how to solve it. CET question, how to solve it. Because in CET, it's not about just solving the question, it's about solving it in the given amount of time. Right? So we need to do both. Let's do the board style first. So I'll not do for every question the board style because this is a CET problem, but I'll show you for this one especially. So basically in the continuous, in the continuity based problems, right? Correct, Baki. It is continuous for the previous question, continuous for entire real number. Okay. So for a continuity based question, you have to solve what? Left hand limit, right hand limit. Basically finding the limits. So you should remember all the standard limits. Sin x by x, tan x by x, cos x conditions. Then we have for exponential function, log functions. You need to remember all those standard limits. Okay? Yeah. So in this question, we don't have to apply that. Actually, this is simply, there are other methods also to find limit, that is called as simplification or factorization. Then we have rationalization. All that is also there. Okay. So in this part, we have to do factorization wala condition. So if you check carefully, you'll find out that for the numerator function, which is x cube plus x square, x cube plus x square minus 16x plus 20 upon x minus 2 the whole square. The numerator, if you check carefully, if you put x value as 2, if you put x value as 2, this will become 0. Means 2 cube is 8, 2 square is 4, 8 plus 4 is 12. 12 plus 20 is what? 32. Minus 16 into 2, minus 32. Take the sum, 0. So the numerator is 0 when what? At x equals to 2. For this value, numerator is 0. What it means? It means x minus 2 is a factor. So what are you going to do? X minus 2 divide with this thing, x cube plus x square minus 16x plus 20, or you can do the synthetic division as well. You can do the synthetic division also, whichever method is better for you, and solve this. You'll find another quadratic factor. Factorize that using splitting the middle term. You get x minus 2 the whole square. That will cancel this part. You'll have something x, I think it is x plus 3 or something like that is left. I'm not sure. Okay, x plus 5, I think. X plus 5 will be the factor over here. Getting it? So you have to find it like that. That is the board's technique to solve it. It will take time, but boards rewards your steps. So you have to solve that way. But for CET, what are you going to do? Apply the simple LH rule. Derivative inside the limit doesn't change the limits. Differentiate that. If I'm finding the value of limit over here, limit of the function, what is that? X cube plus x square minus 16x plus 20 divided by x minus 2 the whole square. When x tends to 2, differentiate. Inside the limit, you'll have what? Limit x tends to 2. Check over here. 3x square plus 2x minus 16 upon 2 times of x minus 2. Achha, why do we apply LH rule? Because you can find over here, this is indeterminate form. If you put 2 over here, no, both of them become 0. So right now they are both 0 by 0. This is called as indeterminate form. Indeterminate form. If you put the value 2 back here, it still will be indeterminate form. So we're going to differentiate one more time. We'll apply one more time LH rule. What will have? Limit x minus 2. Differentiate now, you'll have 6x plus 2 upon 2. 6x plus 2 upon 2. Right? Right? Now put the value. Divide it. You're going to get this as 2 is common. You'll have 3 times of 2 plus 1 divided by 2. So I'm taking 2 common and putting the value x as 2 also in the value of x. Okay, in place of the x. So 2 and 2 cancels. Check, this is coming as 7. For the given function to be continuous, what is the condition? Limit fx at x tends to 2 must be equal to f of 2. F of 2 is how much? K. Hence the k value must be equal to 7. Answer is option A. KCET method using boards. If you want me to, I can show this entire process. So tell me right now, should I solve the entire process also for boards? Can I show this? Do you want this from me? I can do that, right? X minus 2 if you take, you'll have x square over here, right? So you're going to get x square. You'll have this as x cube minus 2x square minus sign plus sign. This cancels. You'll have over here 3x square minus 16x, right? Then you're going to go and get this value as, check, plus 3x, right? Plus 3x. This becomes what? This becomes 3x square minus 6x. Then change the sign. This cancels. This will become minus 10x plus 20. That will be what? Minus 10 actually. Minus 10. That becomes again minus 10x plus 20. Difference if you take, it will become 0. So my factors are x square plus 3x minus 10. X square plus 3x minus 10. Detailed method of CET I did over here. This is the CET method. This is CET method using the LH rule. What is LH rule? It says differentiate under limits. Check carefully. Derivative of x cube is 3x square, x square is 2x, minus 16x is minus 16. Here 2 will be the power, so comes as coefficient. X minus 2 into the power is 1 over here. N minus 1 comes na. Now differentiate again, because we still have, if you put the value over here also, you're going to get 0 by 0. Try to do. Put the value 2. You'll have over here 12. This will be what? 4. 16. This will be what? Minus 16. So 0. Over here, 2 minus 2 is 0. This is again going to be what? Indeterminate form. So differentiate one more time. Apply LH rule one more time. You get what? 6x plus 2. This is 0. This will be what? Simply 2. Cancel 2 and 2. You can take 2 common here, na? 3x plus 1. Now put x value as 2. 3 into 2 is 6 plus 1 is 7. Answer is 7. This is the CET method. This is the board's method. Now you have to factorize this part. X square plus 3x minus 10. Okay. One second. Let me do it over here. So basically we had x minus 2 x square plus 3x minus 10, right? So I can factorize this as x square minus plus 5x minus 2x minus 10. Factorize now. X is common, so x plus 5 minus 2 is common, x plus 5. You get x plus 5 over here and x minus 2, and this is already there, x minus 2. Combine these two. It becomes x minus 2 the whole square into x plus 5. This is the numerator. This is my denominator, by the way. This part cancels. What I get the answer as? X plus 5. The value was supposed to be found at what point? X equals to 2. This was supposed to be found for x equals to 2. So it will become 2 plus 5, which is 7. Board method. Should I repeat any part? Should I repeat any part? Anyone wants me to repeat any part? CET method or board method? Let me know. Any part? Should be repeated? Should be resolved? No, right? Don't be hesitant. I won't judge you. That's not my job. My job is to teach you. Okay? Great. Fx is continuous. Now this is, again, how would you solve it? You have to find the standard limits. Or, see, this will be requiring over here minus x. So standard limits of exponential function and trigonometric function you have to use. Or simply use LH rule. What is that? So we have limit e power 5x minus e power 2x upon sine 3x when x tends to 0. Acha, why do we need the LH rule? Because if you put 0 over here, you'll get e power 0, which is 1. This will also be e power 0, which is 1. So 1 minus 1 is 0. And sine 3 into 0 is sine 0. Sine 0 is also 0. So it is forming a indeterminate form. When you put x as 0, this is forming indeterminate form. Right? So this is both 0 by 0. Now differentiate now. Differentiate. So you'll have the limit same. Check here. This will become, differentiating this part, it'll be e power 5x as it is, into 5 will come. Minus. 2 will be here, e power 2x. Right? I hope so. And then we get this as derivative of sine 3x will be cos 3x. Again, you'll have 3. Derivative of sine is cos and derivative of 3x is 3. Now put the value back. Put 0. You'll get 5 into e power 0, which is 1, minus 2 into e power 0. Again 1. I'm putting x as 0. So e power 0 is 1. Here also e power 0 is 1. And 3 into cos 0 is also 1. My answer is coming as 5 minus 2 is 3. Upon 3, how much is that? 1. How much is that? Option D. Answer is option D. Yes. I hope it makes sense. in the continuity based question of CET, we use extensively LH rule only to save time. Okay. All right, sir. Fx equals to kx square minus 2 and 4x plus 1. Continuous at 0, find the value of k. Okay, we'll put that. So let's find f of 0 from here. You're going to get k times of 0 minus 2. How much is that? Minus 2k. Minus 2k. And let's find what over here? We'll find right hand limit. X tends to 0 plus for 4x plus 1. Check this out. This will become what? This will become basically, if you want to go proper method wise, you'll have this as limit of 4 times of 0 plus h plus 1 when h tends to 0. If you want to go proper method wise, here a value is 0, that's why I'm doing 0 plus h, or will be a plus h. Okay, this becomes what? This is 4 actually here. This whole thing becomes 0 only. So 4 into 0 plus 1. What is the answer going to be? Plus 1. So if the function is continuous, it means LHL equals to RHL equals to f of 0. So I don't have to find RHL and LHL both. Even one will be okay. Because given function is continuous means whatever is RHL, same will be LHL. Right? So this is the case of RHL I have found. But I don't need to find both. Only one is sufficient. Check. RHL equals to f of a, that is what? Minus 2k equals to 1. So k equals to minus 1 by 2. Option is D. Check Bucky, there's some mistake. Hi Jalakshmi, how much? Okay, Comet K round 2. Jaya, I have to check on that, okay, and update you. For all the updates regarding counseling, no, ma'am is actually taking care of it. But I think if there was an update like that, we would have let you know by now. Okay, but I don't think there has been an update like that. But I'll do one thing. You please put your comment in the comment section. I'll ask ma'am to check it out. Okay, and I'll check from my side as well. All right. Please check, guys. This is the right answer, option D, not C. Bucky, please check. Okay, Jaya, please let your comment be in the comment section. Okay, in the comment section you can put your comment and I'll get it checked out. Okay, fx is continuous at x equals to 0. Again, same problem. What are you going to do over here? You have to find f of 0. It means f of 0 over here has to be what? Limit of the function fx when x tends to 0. So let's find this value. Same answer will come for f of 0. So you're going to use what? LH rule. Use LH rule. Achha, we could have used LH rule over here also, guys. If you want to, you can use LH rule over here also. Differentiate. You'll have what? What is the question given? 4 will come over there, and that will come as. Achha, this is not indeterminate form, by the way. Okay, sorry. Yeah. Got it. Let's use LH rule now. Why can we use? Because check here, it will become 2 power 0. 2 power 0. So 2 power 0 is 1. 1 minus 1 is again 0. 0 upon sine 0 is also 0. Correct, na? In this function that is there, check it out. 2 power x minus 2 power minus x upon sine x when x tends to 0. If you put 0 over here, it will become 2 power 0, which is 1. This also will be 2 power 0, which is 1. 1 minus 1 is 0 and sine 0 is 0. So what are we getting the form over here? 0 by 0 form we are getting. Let's differentiate it now. Apply the LH rule. We'll have the same condition. With derivative we're going to get what? 2 power x ln 2 or log 2 over here minus. You get again 2 power minus x ln 2, but there's a minus sign, so you'll have a minus 1 here as well, and sin x will become cos x. Right? Continue. Because when you differentiate x, you get 1, so we don't write 1 over here. But when you differentiate minus 8, you get -1. So we have to write that. Check ln2, nn2 is everywhere. So take ln2 outside. We have 2 power x. This will become minus and minus. So plus 2 power minus x upon cos x, and limit is what? Limit is x tends to 0. Substitute the value. Please substitute the value. X is 0. So you'll get ln 2. 2 power 0 is 1 plus 2 power minus 0, basically same thing. So 1, and cos 0 is also 1. So I'm getting 2 ln 2. 2 log 2. So this can be taken as the power of 2. So log of 2 square or ln 2 square. This is ln or log, same thing, right? So I get log of 4. What I get the answer as? Log of 4, which is the option D. Anybody has doubt in any of the steps over here, please let me know. Anyone knows why it is log ln, same thing? Let me know. Yes. Great. Next, continuity function. We are looking to find the value of k. Let's find the limit. Now I think we can go a little bit on a better speed. Differentiate directly. We'll use directly LH rule over here. Differentiate. 1 will be 0. Tan will be what? Secant square theta divided by 1 will be 0. This will be root 2. Sin becomes cos theta. Then we have what? Theta tends to pi by 4. Check. Sec at pi by 4 is what? Root 2 square. Outside is minus sign. Here also root 2. And cos at pi by 4 is what? 1 by root 2. This is cancelled. Minus minus cancelled. We have the answer as root 2 square. How much is that? 2. This is the limit value. This is the limit value. This should be equal to what? F of pi by 4 should be equal to k by 2. This is k by 2 actually. So k by 2 should be equal to what? 2. This 2, the limit value. So k by 2 is equal to 2. So k is equals to what? 4. K is equals to 4. Check. Check it out. So as we have already informed you, you can all find the link for the free AIO platform, all-in-one platform over here given in the chat. If you click on the link, beta, one second. If you click on the link, let me show you. I'll give you a understanding how it works actually. Just a second. Okay, just a second. If you click on that link, you will visit, you will get a page, and you will click on, basically you have to create your login credential, and this is our learning platform. It's called as all-in-one learning platform. And if you click on this particular course that you want to learn and check, I want to learn, let's say, mathematics, okay, and I have to check my sessions that is there. These are all the sessions conducted by me, okay, on YouTube, given over here as well. You can play from here. You can download your class notes. You'll get access to your doubt solving, assignments, questions. Everything will be given over here only. Let me show you the class notes of matrices one shot. Here it is. Whatever the class notes is given to all of you. So you'll find everything at one place. What you need, how to learn, how you will learn anything. You need to learn from the lectures, the classes. Then you go ahead and get the notes of it. Then you move on and practice some questions. Then you do what? Ask your doubts. And that completes your complete learning structure. Write some tests. So all is available over here in our all-in-one learning platform for completely free. No charge of this. Okay. So take it up. This is your all-in-one learning platform. I hope this is clear, guys. I hope this is clear. Okay. So let's just get back to our class now. Okay. Links have been provided over here in the live chat. Okay. No charge, of course. There's no charge for any of this. All right. The last question of this chapter, this particular topic, I'll give you all as homework. Let me see. Now I remember your names. So I would like to see whether you can, you are simply just coming for the class or you're actually learning from me. So there's a homework today. Whenever I'm coming live, I'll ask you question number 9. What was the answer? Let me check what is the answer though. The answer over here. Yeah, I remember the answer now. So we need to find the value of A, right? Yeah, I know the answer now. So I will need to know from all of you as homework. Yes. So of course, more things will be uploaded bacha later. We're just starting right now. But yeah, we'll try our best to provide you some quizzes over there that you can test yourself. Questions will be provided, practice will be provided in this AIO learning platform. We're trying to make it as much as possible, as good as possible for all of you from our side. Okay? Yes. We still have to get all the support from the team. We're working really hard to get it very soon. But still, there's a lot of improvement there. But it is still very good for your learning, for your, better classroom experience. Please try to use it right away. Okay. Achha, this is clear. This is your homework, by the way. Question number 1 is your homework. I want you to solve both way. Please solve boards plus KCET methods. For KCET method, you're going to use what? I know LH rule. For both method, you're going to use what? Standard limits. How do you solve it? Multiply here a square. Multiply here a square. Here also you multiply a square. So question becomes what? A square times of sine ax upon x. I'll give you the hint of this. A square, if you multiply, you get over here a square x square. And this becomes sine square ax. So what do you have? A square sine ax upon ax the whole square. Where limit x tends to 0. This will become 1. Please solve it. I've given you most of the answer. Still you solve it. Now, next topic. This is on differentiation. So of course, we'll learn about differentiability first. The first principle. So what is it in the first principle? Have a look. It goes like this. Limit of the function x tends to c, when the limit is x tends to c, for f of x minus f of c upon x minus c. If this exists finitely, means if this limit's value is a finite value, let's say this is a value g. So basically, if you find the limit of this, how do you find it? You need to find the left hand limit and right hand limit, and they both must be equal, right? That's how you say the limit exists. In this special case, this left hand limit is called as left hand derivative, and this is called as right hand derivative. When they are both equal, then only we say the limit exists finitely. So whenever this particular expression is finite, this limit is finite, that's called as a differentiable function. It's called as a differentiable function. What is the notation? F dash of c, df of dx, or sometimes dfc notations. How do you find that? When LHD is equals to RHD, so f dash at c from left hand side or f dash of c from the right hand side must be equal. Expressions are what? For left hand derivative, check. Limit, you'll have over here, what are you gonna call? So if let's say approach from left hand side, you'll have f of x minus f of c upon x minus c. But in this case, you can replace x by a minus, c minus h. So f of c minus h minus f of c upon c minus h minus c. Check here, this is cancelled. Notice this condition, limit h tends to 0. This is your left hand derivative. What is this? Left hand derivative. That is my left hand derivative. Okay. If I have to write the right hand derivative, simple. Limit h tends to 0. In place of c minus h, you'll have c plus h. F of c plus h minus f of c upon positive h. Here you'll have minus h, here you'll have plus h. Here you'll have c minus h, here you'll have c plus h. And this is called as right hand derivative. And this should be equal to what? This for the given function to be differentiable. Yes, Baki, we are working on that. Very soon you'll have your chemistry also classes going on our platform. Yes. Okay. We are trying our best to sort that issue. Very soon you'll have an answer for that. Yes. Okay. Let's move on. Relation between continuity and differentiability. What is the relation, sir? If you have any function differentiable at a point, it'll be always continuous. But if it is not differentiable, it may or may not be continuous. It may be continuous, it may not be continuous. Example. So example I took in the beginning over here. Where's the function? Here. So for this function you check, this is having a break. This is not continuous, not differentiable. But if you look at this function, modulus function, this is continuous but not differentiable. Whenever you have sharp edge or corner present in the function or break in the function, that is always non-differentiable function. Where were we right now? 1 second. Here. Yeah. So if it is not differentiable, it may or may not be continuous. If it is continuous, it may or may not be differentiable. As I mentioned, mod of x is continuous, but this is not differentiable. Okay. Great. Fx is discontinuous. If a function is discontinuous, it will never be differentiable. If it is discontinuous, it is not differentiable. Clear? So differentiable means continuous. If it is not continuous means it is always again not differentiable. All right. Great. Some relations. Any doubt in any of these parts? Now some standard derivative of different types of functions. Polynomial, trigonometric functions of all these. Exponential function, logarithmic function. Exponential function with the natural base. Log function with the natural base. And a constant function. Derivative of these is what? 0. This is 0. Please check. I know very well, all of you will know the derivative of these fundamentals functions, right? N into x power n minus 1, cos is minus sin, sin is plus cos. Tan is sec square, cot is minus cosec square. Sec is secant into tan, and cosec is minus cosecant into cot. Right? Yes. Clear, sir. Some differentiation rules also are there. Acha, let me just tell you one more thing as well, since I'm teaching this. For ITF also I'll tell you over here only. For ITF. Acha, in next, which is the part 2 of this session, when I'll have this live, in the part 2 of this session, I will discuss parametric form, logarithmic differentiation, second order derivative, and inverse trigonometric functions questions. I'll discuss all these in the next class. And then we'll do one session for KCET PYQs or board PYQs. Okay. So one for the question practice. Clear, right? Okay. Let's do ITF functions derivative now. So derivative of sine inverse of x is what? 1 upon root of 1 minus x square. Derivative of cos inverse of x is what? Minus 1 upon root of 1 minus x square. 1 is here. Next. Derivative of tan inverse of x is what? 1 upon 1 plus x square. Derivative of cot inverse of x is what? Minus 1 upon 1 plus x square. Next is what? Derivative of sec inverse of x is what? That's 1 upon x times of x square minus 1. Derivative of cosec inverse of x is what? That's minus 1 upon x times of x square minus 1. Can you see the similarity in all these 6? The pattern in all the 6 inverse trigonometric function? That'll be next week. That'll be next week. That'll be next week. Okay? Yes. So I don't want to rush you or burden you. And we'll have very soon even, so what we're doing right now, no? We are solving questions, learning concepts in a series, which is a live session, okay? That is going on in the evening lives. But we are also giving you a one-shot consolidated lectures for different chapters. So next week you're gonna get for determinant, and again for the next week you're gonna get what? One shot of all the chapter, which is this particular chapter, C and D. Okay, so every week you're getting one shot for PUC number 2, like second PUC, and one shot for first PUC. We have already covered the 3 chapters one shot so far. 4th will be coming next week. Okay, so every Tuesday you have a second PUC one shot lecture at 8 p.m. Maths. I'm just talking about maths. If you want us to do a detailed understanding of or explanation of how the lectures are going on, that's why just wait for some time. Let us sort the problem of chemistry also, and then we'll give you a proper plan on what days it is coming right now. For now, just understand this. Every week you're getting one second PUC one shot, one first PUC one shot, and the lectures live as well. All this is available in YouTube as well as in the learning platform AIO. Okay. So I would recommend, if you want to watch us live, you can come over here as well on the YouTube. For recorded lectures, you can, again, if you want to rewatch it, you can simply check out on, basically in the AIO platform. Now, differentiation rules. Constant rule is derivative of any constant is always 0. Any constant. Rational, irrational, doesn't matter. Scalar value means if you have a constant multiplied to the function, you can take the constant outside and differentiate the function. Sum or difference rule. If you want to differentiate the sum or difference like this, you'll have the answer as f dash plus minus g dash. You can differentiate the function individually and then add or subtract. Next is what? Product rule. When you have two functions together. So when you differentiate the functions together in taken in product, you can take one of the derivative and then keep the second one as it is, and then differentiate the second one and keep the first one as it is. Let's say if you have f, g, and h, 3 functions derivative in product, how will you solve it? F dash, gh as it is, g dash, fh as it is, and fg, h dash. In the case of product rule, there is no preference. There is no preference. Reason very simple. You take this over here or this over here, does not matter. If I want to differentiate, let's say g first. Okay. You differentiate over here, then keep it back over here. In addition, in the case of addition, what happens? The order of addition is not same. It's not making any difference. So a plus b plus c or b plus a plus c is same. That's what it is. But this is important. In the case of quotient rule, then the things will change. Over here, the preference is given to numerator. So you take, if it is f by g now, you differentiate. If you're differentiating this, you'll have to differentiate f first, g as it is, and over here you have a minus sign. F as it is. Now derivative of g divided by always g square. Always g square. Correct. UV rule. Correct. UV rule. Right? These are the rules of differentiation. Chain rule and implicit differentiation. Okay. Chain rule is what? When the function f is a function of another function. When the function f is the function of another function g. So you'll differentiate the outside function f first. You don't go from inside to out. You'll go from out to in. Differentiate the outside function first, then take a multiplication. Differentiate the inside function next. Keep doing so until unless you reach the last function. You don't have to take only 2 functions. You can have 3, 4, 5 functions like this. You have to do that in chain. That's why it is called as chain rule. And attach all of this with a multiplication sign. So chain. Like this. Next is what? Implicit differentiation. So usually you find the function written like this, y equal to fx. Means y is given as clear subject. Clear subject. But it will not be the case always. You can find many questions where it's not given clearly y as subject. Means it is not clearly explicitly written in the function fx. In those questions, we have to differentiate it as a equation. So differentiate both sides, treating y as a function of x, solving for dy by dx. Means you'll have an equation over there. You'll differentiate this entirely to get the result in that. Don't worry, I have taken question like that. I'll solve in the class. Next is logarithmic differentiation. Okay, so you have u to v form. Whenever you have this, basically 3 forms are there. F to g form, f into g form, or f by g form. If you find functions, 2 separate functions taken as powers, taken as product, or taken as quotient, and you're supposed to find what? Derivative of each of these. What you do? You take log, log of this will become what? G log f. It'll become, G will come outside as the coefficient, so G log f. Then you differentiate. This will become what? Log f plus log g. That will become what? Log f minus log g. So you use these conditions to find, whenever you have these 3 conditions, you use logarithmic differentiation conditions, basically taking log on both sides. This is the first question on the chain rule. The first problem on the chain rule. Right? Can we solve it? This is clearly an explicit function given as secant of tan of root x. Tell me how many functions are there. I will not ask you to solve this question. I will ask you to give me how many number of functions are present in this. Please tell me. Numbers of functions present in this. Let's see who gets it right. Three. 3 is right answer. But sometime if I had over here y, if let's say I have secant of tan of root y, and I'm supposed to find what? Dy by dx. Then how many functions I'll have over here? How many functions over here? Correct. Very, very, very good. Extremely good. It depends upon what is the variable over here. So the first function beta over here is secant. Second function is, sir, what? Tan. And the third function is what? The root x. So we'll apply derivative of all the functions in the chain. Start. Dy by dx. Differentiate secant. That is what? What is that? Secant of tan root x. Secant theta derivative is what? If you forgot, let me tell you. Secant theta derivative is secant theta tan theta. So whatever is inside, this is basically the theta value. So secant theta tan theta. This is for first function. Next, let's do into and then write over here. Derivative of tan. That is what? Secant square the angle over there. Angle over here is what? Root x. For this tan, secant square angle here is root x. Next is what? Derivative of root x. That is always 1 by 2 root x. Now if you combine all this to write the final answer, you will have secant square root x, secant tan root x, tan root x, upon 2 root x. 2 root x. 2 root x. What is it now? If you are thinking what is the difference between your one shot lectures or the live lectures? Live lectures I get to have more clarity with you. You can ask me doubts live in the class. First advantage is that. That's first difference over there. Second difference is here I don't have to rush through anything. I can take more time. In one shot I have to complete everything in one class. So of course this will be little slower in nature. I'll take your doubts. I'll get to talk to you more. Okay, but one shot lecture is a very good way of revising concepts, because if you think you have mastered a chapter, then do one thing, write a KCET PYQ test on that chapter. If you get out right from there, then don't ever learn that chapter again till your KCET examination revision. But if you're not able to solve the MCQs or the KCET style questions of that particular chapter, it means you still need the revision of that particular concept. So please do not think, I know you all will think in a way that, sir, I have done already FA1 now. Why would I revise matrices chapter now? Why would I revise determinant chapter now? If you think you are prepared, do one thing, determinant PYQs you take and solve all of them. Last 10-15 years PYQ you take and solve all those questions. And then you tell me how much you are prepared. If you are not getting out from them, those are questions that you've already seen. How do you solve a new question in the determinant? So please never think in a way that just because I have given a test on some chapter, just because I have prepared or studied one chapter, I will not revise it again. I'm not asking you to watch my entire lectures. Download the PDFs. Revise that at least. What is stopping you? There's no charge behind any of these things, right? Given for free. Please do not take it for granted. I have done that in the past and I have regretted it. Please do not do it. Yes. Prove that the function fx given as mod of x minus 1, x belongs to R, is not differentiable at x equals to 1. I have to do what? Find the differentiability at this point. So I have to do what? LSD, RSD. Let's start with LSD first. How do I solve this? Limit h tends to 0. Okay. In place of this, we'll have what? F of a minus h, na? So f of 1 minus h minus f of 1 upon minus h. That's the rule. Different derivative. Put it over here. You'll have 1 minus h minus 1. And over here you'll have what? F of 1 means simply 1 minus 1. Correct, right? Upon minus h. Limit h tends to 0. What I've done? This is f of 1 minus h. So replace x by 1 minus h minus 1 over here. And this is f of 1 means 1 minus 1, that is 0. This part is 0. Here 1 and 1 cancels. What I'm getting, please check. Limit h tends to 0. Mod of minus h upon h. Sorry, minus h. Continue. Limit h tends to 0. Mod of h is what? Positive of h. Positive h minus h. Cancel them. What is the answer coming as? Simply minus 1. This is what? This is my left hand derivative. This is my left hand derivative. This is a board style question, by the way. Solving for boards. For CT, I'll tell you the method if you want to know. Right hand derivative. How do you solve it? Same, sir. Limit h tends to 0. F of 1 plus h minus f of 1 upon plus h. Plus h. Continue. Put the value over here. We get, sir, 1 plus h minus 1 minus 1 minus 1 divided by h. Limit h tends to 0. 1 and 1 cancel. This is also equal to 0. So I get here mod of h upon h. Limit h tends to 0. This becomes what? This will become h by h. Cancels. Answer is 1. So RHD is 1, which is not equal to the LHD, which means what? The given function is not differentiable at the point x equals to 1. I don't think I can simplify this any further. Yes, Mr. Iconic, I remember your name. Yes, yes. How are you, Mr. Iconic? Yes, yes. Bucky, don't worry, don't worry. I have lot of tricks. I'll give you all. Just right now, this is the time to learn the concepts properly. But before you go for the CET, I'll give you a lot of tricks where it is possible to apply and save time in the questions. And many tricks. So I can give you the exact applicable formula kind of trick is maybe 15, 20, 25, like that across all the chapters. But there are many tricks which is applicable inside the question after you see 1 or 2 steps. So I keep telling that in the question solving. Just be consistent. I'll prepare you for everything, okay? Don't worry. I got 97 in maths, sir, and overall 92.5. Super, Mr. Iconic. Super proud. I remember your name. Your name is iconic, so I remember your name. You are one of the consistent student in our classes. Very lovely to see you in the chat. I hope you are doing good, and all the best for your future. And congratulations to everyone who knows you, your family, your friends, your teachers, your parents, everyone. Super proud. This is a similar question, guys. This is a similar problem. Instead of mod, this is what? GIF of x. GIF of x. Okay. So, sir, then it is a different problem. No, how is it similar problem? You're looking to find non-differentiability. How will you find it? LHD not equal to RHD? Sir, still not same problem. Let me show you. LHD will find first. Limit h tends to 0. F of, let's say it for 2. 2 minus h minus f of 2 upon minus h. Upon minus h. So we'll go over here. We'll write this as limit h tends to 0. Put here 2 minus h. 2 minus h. Okay. Minus. Sorry. Minus h. Okay. Minus h. Check over here. Check this value. If you approach, you're welcome, Mr. Iconic. Now, if you approach this value from left hand side, what will happen? Think about it. What will happen? What will happen? Anyone idea? Anyone in the class? Anyone in the class? Tell me. In the limit write this RHD also. So we'll have for RHD limit f of 2 plus h minus f of 2. H tends to 0. This is plus h. This is plus h. Check over here. Okay. So you put this as 2 plus h. 2 plus h inside this minus 2 upon h. Limit h tends to 0. What is happening? This value is, sir, 2. Any value which is close to 0, more than 2, plus 2 will be what? 2. So I'm getting over here what? 2 minus 2 upon what? H. Upon what? H. This becomes what? 2 minus 2 upon h. Sorry, I did not write the limit part. 1 second. I forgot to write the limits. 1 second. So limit h tends to 0. This is what? 2 minus 2 upon h. And what is this going to be? Can you tell now, right? I'll take that. Bucky, give me some time. Let me complete this question. For this one, we'll have the condition as, check, we'll have limit, this will be what? This will be coming as 1. So you'll have 1 minus 2 upon minus h, and h tends to 0. So check this value. This is becoming 0 by h in the beginning itself. Yes or no? This value here is becoming 0 by h. Before you put h as 0, this becomes what? 0 by h. So this is equal to what? 0. Are you thinking this is, sir, 0 by 0? It is not 0 by 0. When you put 2 minus 2, it is already 0. You're not putting the value of h so far. If you simplify the numerator right now, you get 0 by h. So you don't get chance only to put h as 0. So answer is what? 0. Means your RHD value is coming as 0. Whereas what is the LHD? This is coming as, check here, limit minus 1 power minus h. If you put over here, you're going to get this value as plus infinity. Are they equal? LHD is not equal to the RHD. What it means? Non-differentiable. Non-differentiable. Same you can do for x equals to 1 also. This is, by the way, for board understanding, for board type of solving. For CET, this is clear, right? 1, x equals to 1 and 2 are what? Integers. What happens? This is discontinuous. So, non-differentiable. For CET, you have to look at options. Their integral value, that's why non-continuous and non-differentiable. Clear? Okay. All right. Anyone has doubt in any of the steps I have done? I can repeat it. Anybody has doubt? I can repeat it. So how to solve y equal to root x to the power root x and so on up to infinity type of problems. I'll give you a hint. You try this first. I want you to try this first. Y equal to root x power root x power root x. Remove this from here. You're going to get what? Y equal to basically root x power y. Try this now. It'll become y power, what is this going to be? X power 1 by 2 power y. So 1 by 2y. From there you can solve. Try this now. Try it now. Ask me later. Try it. Y equal to root x power root x to power root x. So whenever this kind of question is there, no, try to use this method. This whole thing, if from infinity you take one part out, it is still what? Infinity only. So that is y. So root x power y. Root x power y. And what is root x? Power 1 by 2. So x power 1 by 2 power y. So y by 2. X power y by 2. Y equal to x power y by 2. You have to freeze that. Try this once. This question is an example of where y is not given clearly. Implicit functions. Differentiate it. 3x square. This will be an application of product rule because your two different functions are there. So differentiate x square, you will have 2x, y as it is, plus x square as it is, y will become dy by dx, plus x will be 1, y square as it is, plus x as it is, y will be y square will become 2y dy by dx, plus 3y square dy by dx equals to 0. 81 is a constant, so 0. Now from here, take everything which is having dy by dx. So this term, excuse me, this term, and this term. Take dy by dx common. You end up with x square plus 2xy plus 3y square. And everything else you move on this side. This, and this. You'll get minus 3x square minus 2xy and plus y square. Move on that side. That's my answer. Minus 3x square. Sorry. Upon this is clear. Please check. Correct. Correct. This is also example of implicit function only. We differentiate like a equation. So we get first 2 sine y. This is for sine square. Now we are going to differentiate sine y. That is what? Cos y. Now what are you going to differentiate? Y. That's dy by dx plus derivative of cos. That's what? Minus sine. So minus sine xy. That is for cos function. Now we have xy inside. We'll use chain rule again. So we'll have x as 1, y as it is, x as it is, y as dy by dx. Pi will be 0. Check here, this becomes sine 2y. 2 sine y cos y is sine 2y. dy by dx. Expand over here, you'll get minus y sine xy and minus x sine xy dy by dx equals to 0. So we'll move this term over here and take dy by dx common. We get sine 2y minus x sine xy. So it will become y sine xy. Divide it. That's my answer. Y sine xy upon sine 2y minus x sine xy. Check. Right? Okay. Come on. Another form of implicit function for board style only. Differentiate it. So in today's class, I have taken more of board style questions. Okay. I have some CET as well. Just coming, I think after this is CET style only. Yeah. But this is also board style. I've taken a lot of board style question to help us, build that foundation for the chapter. Okay. Differentiate now. Implicit function. So 2x sine y becomes cos y dy by dx 2y dy by dx. Log will be what? 1 by x plus y into x will be 1 dy by dx. Please check. Now I need to find dy by dx, so I'll separate. So let me do one thing. I'll move this over here. And this constant term I'll move on this side. So I'll get 2x minus 1 upon x plus y. And over here I'll get 2y dy by dx plus 1 by x plus y dy by dx, and this goes over here. So minus cos dy by dx. Cos of y actually, sorry. Cos of y dy by dx. Take LCM. We get here 2x square plus 2xy minus 1 upon x plus y. And over here what do you get? Check. Dy by dx is common. Now take LCM over here of x plus y. So you're gonna get over here 2y times of x plus y. Over here you'll have what? Plus 1 minus cos y x plus y. Check. This part is cancelled. My final answer. Dy by dx becomes equals to 2x square minus plus 2xy minus 1 divided by this big bracket. Okay. So this becomes what? I can write it like this only. 2y x plus y plus 1 minus cos y into x plus y into x plus y. Y sin xy sin 2y minus x sin xy. I think that was the previous question, right? Correct. Right. Answer. 16th one. I'll give you time to solve this. MCQ, so please give me the option. Give me the suitable option. Give me the suitable option, please. X equals to cos xy, find derivative. Also implicit function. Anyone answer this, please? Please answer this question number 16th. So we have 16, 17, 18, 19. We have 4 questions left. Answer this, please. Simple, right? You'll have derivative of x as 1. Cos will become minus sine xy. And over here you'll have for derivative x as 1 times of y plus x times of y dy by dx. Sorry. Dy by dx. Right? So 1 equals to minus y sin xy and minus x sin xy dy by dx. Moving on this side, you'll get 1 plus y sin xy equals to minus x sin xy dy by dx. Let's check if this option give me any result. 1 plus y sin xy is in the option A, B, C. There's a minus sign, means overall you'll have a minus sign over here as well, right? This will be moved on this side, right? So you'll have minus of 1 plus y sin xy, and move on this side, you'll have x sin xy equals to, that's the only one option, option A. That's the option A. Correct. Only option with a negative. That's true. So yes, so not every question will have trick, but you can see after the second step you can visualize only one has the negative answer. So option is A. Okay, this is the kind of basic understanding that helps you in the question solving. But yeah, what about this? X root of 1 plus y equals to minus y root of 1 plus x. Square both sides. Check. You'll have x square 1 plus y equals to y square 1 plus x. Expand, please. X square plus xy and y square plus xy square. Move everything on this side. So we'll have x square minus y square plus x square y minus xy square equals 0. Factorize this. You have x minus y, x plus y, and over here take xy common, you'll get x minus y. Correct now? You get what? xy is common, so you get x and y left. Continue, please. You'll have what? You can see x minus y is still common. Okay. In that case, this will be what? X plus y plus xy equal to 0. I take this common, you have x plus y left plus xy equal to 0. Can y be equal to x? No. Y can never be equal to x. Check here, this will become positive entity. This will be never non-zero, never zero basically. So y cannot be equal to x. This is not equal to 0. So it means this must be equal to 0. If you have product of two values equal to 0, it means if one of them is not 0, this will be equal to 0. Check here. You get y plus x plus xy is equal to 0. Take y common from here. You get what? 1 plus x equals to 0. So y into 1 plus x equal to minus x. So y equal to what? Minus x upon 1 plus x. Minus x upon 1 plus x. Now differentiate this. Quotient rule. This will become what? Minus 1. This is as it is, 1 plus x. Minus sign, minus x as it is. And differentiate 1 plus x as 1 divided by 1 plus x the whole square. Let's look at the option. Only 1 is there with that option. Option C. You get here minus 1 minus x. This will be plus x. You will cancel. So answer is option C. Answer is option C. Correct. Last two questions. Last two questions. This one. This is again a board style. Again a board style problem. Very simple. dy by dx is equal to what? Differentiate the first root. You'll have, whenever you have root, same root comes as 1 by 2 root that. Same root comes like this whenever you have a root. Now differentiate what is inside the root. You'll have 0 for this part. Then you'll have again this same thing, root will be acting the same way. 1 by 2, same root will come over here. And differentiate this part now. So 2x. Take 2 and 2 is cancelled. My answer is coming as x upon 2 root of a square plus x square into root of a square plus x square. If you want to multiply, you'll get the answer as a square plus x square. If you want to multiply it inside, actually of no use, but if you want to do it, you can do it. This is the result. This is the result. This is fine. This step is sufficient. Until unless you have a different option which gives you a better result. This one you all solve. This one you all solve. Last question and then I'll end the class today. The last question, then I'll end the class today. I've given you a hint of this question last class, which was the FA1 sample paper wala class. Come on, give me an answer. Shall I give you a hint? 1 minus cos x is 2 sine square x by 2. 1 plus cos x is 2 cos square x by 2. Now tell me. Now tell me. Y equals to root of 2 sine square x by 2, root of 2 cos square x by 2, 2 and 2 cancels, tan square, root will be there, so becomes tan x by 2. That's why derivative is what? Correct, A. Sec square x by 2, and derivative of 1 by 2 will be, sorry, x by 2 will be 1 by 2. So answer is option A. The answer is option A. The answer is option A. This was the answer. This was the end of all the questions that I've taken for this class. If I missed something, let me know. Okay. And again, we have provided a link of the AIO page for all of you who are joining late. We have given the link of the AIO page in the chat as well, in the description also given as free PUC KCET 2027 batch or course. Check that out. You'll get to this particular platform, learning platform, by logging in. okay, by creating the login credentials, and start learning with us. Start learning with us. Nothing else. Anything else you want to ask me, I'm here to help you with that. Okay, this was the class about your first part of continuity and differentiability. So if you are new, do subscribe to the channel, because everything that you do supports us, gives us energy, gives us, you know, basically motivations to come back here and deliver the classes. Okay, this is a to and fro, means your support helps us work here, you know, and provide you the academic support that you need for your preparations of CET boards, whatever we can do to help you out. Okay, subscribe to our channel, share this with your friends, whoever you feel that will benefit from our lectures. If you feel we are, you know, doing okay at least, okay, and like the class if you found it useful, and wait for the part 2 of CND. Yes, Abhyas, like Abhyas will have a test series for KCET as well. Yeah, it'll be there. One of the best test series out there, one of the best KCET centric test series which is there, is given by us only. We've got outstanding reviews, outstanding results from Abhyas. Okay, our basically are the our most popular, you know, one of the most popular. Even our crash course was very popular, but one of the most popular course is Abhyas KCET test series. So we are working around. We'll see if we can get it early this time, so you can practice more and more questions. We are trying something. Give us some time. Let us focus. Next 2 months now. Next 2 months is very important for all of us, because in next 2 months you'll have a midterm. August, September you'll have. This is the 2 months that you are left with. September end or October 1st you'll start your midterms. And trust me, after October you'll not know how November meant. October entire will go in your midterms. November will be 1 month, and December starts your what? December starts your, you know, the journey of preparatory and everything. So understand this. August, September is only time that we have to complete the portions, to do a rigorous study. October gone for midterms. November you'll have 1 month. You'll not know, the fastest month that goes is November. Okay. November goes, December is your pre-preparatory starts. 1 or 2 preparatory will be there. Then again you'll have February, you know, your practicals, March exams, April CET. So it'll not be that fast. It'll not be, you know, that slow. So please understand this, very important. So got to know from Gagan Virai, was watching his experience, and Prajwal also. Okay, so that was year to year, like 2 years back. Prajwal and Gagan was, yeah, senior of your seniors. Correct. They're doing very good, by the way, by now, right now. Gagan to studied only from YouTube actually. He didn't take any of the course, only take the test series, took the test series. Yeah, we met them. We had a nice lunch with them, you know. We had an event, so we all met. There was a video. We just did nice photo shoots. There was a prize distribution. Everything was there. A lot of things was there. Yeah. There was a nice, I think, 5 to 6 hours of time we spent together. Yeah, we had a nice time together. Yes. Last time we missed out on that because there was a lot of, you know, last time we didn't have much time between Comet K and CET. Then yeah, we did not do that. But yes, we'll try this year. Okay. So anything else that we can do over here in the class? Any doubt I can take? You all are welcome to do it. Notes you'll find in the AIO page. So this session will be uploaded over there, and you'll find the notes attached over there as well. Class slides, you'll find the notes over there. It might take a day or so to upload it, but we'll upload for sure. Okay, let's utilize our next 2 months. Let's get more academics in the next 2 months, and then we will not have much time left. Trust me, believe me. Okay, then we'll be in panic mode. Every minute is very important. Right now we are relaxed. Let's study properly with a structure. We'll do good. Okay, chalo. So that's all in this class. We'll see you next time in the next live. And of course, you have Tuesday one shot coming for determinant. Please not take it for granted. Until unless you can solve all the PYQs of any chapter, you are not prepared properly for the chapter. So revise seriously. Okay, that's all in this class. Yes, you can concentrate on both JE and KSAT. For KSAT, you have to, if you're preparing for JE properly, very good. For KSAT, you have to just, do what? You have to just simply give your test, basically uh, do a mock tests of different chapters. Okay, try to do a time practice, 60 minutes, 60 questions to solve. So make an habit of that, and give your complete focus to JEE, because JE first attempt will be coming, right? So give your complete attention to the JEE, and CET just do a weekly mock test for you. Will bring something for you. PYQs is a good start. Good start. It's not all. We'll provide something like that. Don't worry. We are working on a test series. Very soon we'll be giving you that. 20 years PYQ, good, but you have to check whether it is out of syllabus or not. Usually what happens now, there are a lot of out of syllabus questions given, so you can't solve that. So use between, always use time practice. 60 questions, 60 minutes. 30 questions, 30 minutes. 20 questions, 20 minutes. One question per minute you have to take. But don't solve one question 1 minute, okay? 1 second. Correct. So try to go for complete focus for JEE and mock test preparation for this. That's all, guys. That's all in this session. I'll see you next class. Take care. And all of you who are busy with other preparations, I would request you, for revision of CET side, you can refer my notes. If your JEE preparation is on track, means your notes, this notes will be helpful to revise those concepts, and you can do it faster. I don't want to waste your time. Okay, it's not like I want you to be here only with me all the time. I would love that, but you have a priority. If you're writing a JEE examination, I cannot say just stop JEE. Can't do that. If you are good at it, you should certainly be very much focused for it. You have time right now, but do not forget about CET. CET can help you a lot. Okay, I've seen a lot of stories, phenomenal stories from CET examination. So please take it seriously. Do a mock practice. Do a lot of mock tests, practice of questions. Refer my notes. Refer my classes. Yes. Thank you, Baki. Okay, so yes, I'm just trying to tell you, for people who are very busy with their, the schedule, you can use this way. But if you can attend the classes, will be certainly helpful. So that's all in this class. I'll see you next time. Till then, take care. Happy weekend. And yeah, had a lovely class with all of you. Bye, Baki. Bye, everyone. Bye, Akash. Bye, Iconic Sir, Mr. Iconic. And beta, please use your learning platform. Okay, it's provided and made for all of your benefit. Okay, so try using it very sincerely and very, wisely. Okay, that's all in this class. Nothing else I can see. Welcome, and see you in the next class. Take care.